10, 11, 12, 13, 14. You remember that method? Like you 14, go up and then the slope being 1. Oh, it's negative here, so I'm glad. Do you see this? It's the slope being -1. Negative is the same thing as -1/1. Now, here's the thing, right? When it's negative, you have to expect that from left to right, it's going down this way. It's going down that way. So you don't have to worry about, hey, I'm going down, right, whatever. Just go ahead and do the 1/1, right? 1/1. But you have to go down this way. So, hey, do 1/1. Should look like this: 1/1, 1/1, 1/1. Or you can think of rise down 1, run over 1. Rise down 1, run over 1. But make sure you run in the direction where it's making it going down like this. Okay, now, if you think about this for a second, right? If your y-intercept is 14 and you're going exactly 111 or 45 degrees, it will have to hit the x-axis at 14. Could you imagine that? It will hit it at 14. I don't know if you could like think geometry, 45 degrees, you're cutting it, a square, you're cutting a square. That means this side and this side must be congruent. That's why it got to be 14. If not, you can still rise, going rise down, run 1. I know, rise down, run 1. Keep doing that. It will hit 14. Yeah, if you want to convince yourself that way. But don't worry too much about this. You may have to actually do it no matter what anyway, when it's not 45 degrees, when it's not 1, 1, like -1/1. Let me count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So here's my 14 over here. So you have to get all the way down like that. But the graphing is kind of like awkward because this is not a good function, the y or equation. It's not a good one because it's too big, it's too far. 14 is too far. So if you guys sketch it by hand, you might not get the actual intersection. I think you can imagine that. Okay, watch. This one. And then we'll come back to the intercept later. I'm sorry, I kind of bring that up because I think it's I'll bring it in later again, the x and y intercept. But let's do it with the slope intercept first. So go down 4 for the second equation. 1, 2, 3, 4. Since this slope is 1, right, in front of the x, it's 1/1. And it's positive. You have to go this way when it's positive. It's going up. So at -4, put a dot there. That's your y-intercept. Rise 1, run 1, rise 1, 1. Same thing. It will be 45 degrees. Therefore, it's going to hit the other one at 4. So I forgot to label this 14. This being -4. Is that okay? Because you went down -4. And then it will hit it right here. So here it is. If you connect them. Here's the problem. You have to do it perfectly for you to get the intersect right here. If you don't have the graphing paper, it might not be great. You can try to guess it, but you can also solve it, like adding or substitution, right? But okay, so let me see. Let me do it. Let's see if I can get this right. Like 1, 1 here, 1, 1, all. See, look, my sketch is still already wrong. So it looks like the intercept is right there. You have to go up 1, 1, 1 from the 4 here, like this, if you have graphing paper. And it looks like right there. This is the intercept. So the intercept will be at, let's see, 4, 5, 6, 7, 8, 9. 9 for x, comma, 1, 2, 3, 4, 5, 5 for y. There you go. And I'm going to check the answer right now. And it looks right. So you check the answer, right? X being 5, X being 9, Y being 5. Go ahead and plug it back in there and check. Yeah, 9 plus 5 is 14, and 9 minus 5 is 4. So it's correct. You see it? Is that okay? Now, again, I don't think this is a good problem because it's too far out, 14. If you don't have graphing paper, that's bad. You can imagine, right? Trying to sketch it perfectly, no way you can get it. So this is a bad problem. Unless it's mandatory that you have a graphing paper, then okay. Then okay, that's fine. Okay. Yeah. X and Y intercept, I think we have to do it. Let me do it quickly. You can watch me do it, okay? Just in case this is what your teacher wants. So if your y is 0, I'm using the first equation as is and the second equation as is, but I'm going to use it for the x and the y intercepts. Okay, I'm going to do both of them. Have a look. Okay, quickly, just quickly. Then we'll move on. Okay, if my y is 0, if my y is 0 right here, if my y is 0, based on this, right? If my y is 0, my x is 14. There it is. I got it right there. Now, staying on the first equation, if my x is 0, if my x is 0, x minus 0, my y is 14. That's why it's over here. See, it's going to be over here. So you have to connect it all the way through. There it is. So that's the x and y intercept method. But you have to know why that works if you can. Okay, watch. X intercept is like this, bunch of x intercept, right? Your x intercept is when your x is unknown, your y is always 0. X is unknown, but it's negative over here. Your y is 0. Negative over here. You don't know what x is, but your y is always 0. That's the concept. That's why you set up that, table. Sometimes they don't do table. They just do it something like this. Then y-intercept, here we go, y-intercept looks something like this. It doesn't matter. But your x is always 0. Your x is always 0. But your y is something. You don't know. You solve for it. Get it? Like that. Over here will be negative y, but your x is always 0. That's the concept. So you can do that and then, connect the 2 points. So maybe we should do it for the next one. Anyway, that's done for 15. All right, let's go to 22. Yeah, let's 22. All right, let's see. Oh, 22 is fancy. I'll come back to this one. Let me start a new one. Done. 22 looks fancy. Sorry. What am I doing? All right. A perimeter of a rectangle is this much. Let me read the last part before I actually do anything. Solve the system by substitution. Okay, so we're not graphing. So, okay, I'm glad. I'll go back to the graphing again just to reinforce the concept, the x and y intercept and the slope. So 22. Perimeter of a rectangle is 48 inches. The length is 6 inches greater than the width. Okay, try again. Remember that printed handout sheet, that thing that we went over? Same idea, same type of problems. Go for it. How would you write the first equation? Perimeter is a rectangle of a rectangle is 48 inches.
Okay.
First equation.
So I'll probably define the variables first.
Oh, yes. Sorry. Let L be the length and W the width. TH. And let's write the equations.
Okay, so
Yes. The perimeter of a rectangle.
I would put L equals.
Wait, which one? Okay, you're doing this. You're doing the length. Okay, length equals what?
Length is 6 inches. Length is 6 plus W.
Yes. Now, if you know this is actually true, I would recommend you put W plus 6. Is that okay? Yeah, switch them around. Make them standard looking. You don't have to, but remember what I was saying about like the less than, like 6 less. You always have to put in the back. So might as well train yourself to actually do the plus or the subtract right behind the variable. You don't have to for the plus, the greater than. But yeah, I recommend you do it. I recommend because they write it like this in textbook in examples and even in solutions. If they want you to set up the equation, just the equation, or sometimes they show everything. Anyway, what about the perimeter? You need the second equation.
Okay, so second equation would be L plus W equals 48.
Say it again.
2L plus 2 like W.
Yeah, you got it. Yeah. Okay, now let's solve, right? Okay, now before you solve, check this out quickly. Okay, check this out because this can be done pretty quickly. You see the 2, 2, 2? I mean, sorry, even numbers. If you know that they're actually even numbers like this, you want to divide everything by 2 mentally if you can. Watch. Rewrite this equation. Now, don't slash it. You can just kind of scratch it or just leave it alone. It'll become 2L, I'm sorry, L plus W equals 24. Do you understand why I would do that? You'll lessen the work when you substitute it. Is that okay? You're basically make it like you reduce it. you make the equation smaller. They're equivalent to each other. Okay, so now you can kind of like ignore it. Your teacher will be fine, I promise. We're still going to do substitution. We're going to put that in right here. So yeah, if you want, you can still work with the 2's and the 48, but you can imagine it'll be blown up a little bit with the 2's being distributed in. But I recommend you do something like this because you can have bigger chunk than this equation later on. So anyway, here we go. It looks like this now. Just substitute it in the second equation. It equals 24. Again, you don't have to do the, divide everything by 2. What I did was divide both sides by 2. So I forgot to show that work. Divide everything by 2. And you have to show that kind of work there. So anyway, it is 2W combined like terms plus 6 equals 24. And then subtract both sides by 6. What is that?
18.
18. 2W. Then divide both sides by 2. So W equals 9. So the width is 9. We may have to write inches here, right? Inch. Circle that or leave it alone and then plug it back in here. So you plug it back in, it'll be the length will be 9 plus 6. I still write L equals 9 plus 6 so your teacher knows what you were doing, what unknown variable that is. Okay, so that'll be 15 inches. I think that's good. Is that okay?
Yes.
See anything else? Yeah, looks good. Yeah. All right. 18. Yeah, looks good. Next one.
31.
31, okay. All right. Oh yeah, of course, you can define the variable, but let's read a little bit. Cristiano bought 24 baseball cards for $50. One type cost $1 per card. The other cost $3 per card. Define the variables. Okay, so let's define the variable here. There are 2 types. So I don't know. They tend to do something like this. Shall we do X and Y again? Is that okay?
Yeah, that's fine.
Let X be type 1 card. Type 1 card. Let Y be type 2 card. Or the other type. You can also do that. That's very casual. This one is more type 2. This one is a little bit more, I don't know, specific or technical. Okay. Now, how would you set up the equations? Now, they're actually giving you the most common ones that you would find on the test or quiz, for sure. So, and I don't think you'll have any trouble. But let's set up the equations. How would you do it?
So I'll probably do X plus Y equals 24.
Yes, the number of cards. Yes, 24. Yeah, hey, some people will do something like this. Let X equals the number of cards. I don't know, type 1 number of cards, but I think you should be fine. Or put cards here, type 2 cards. That implies that there are a number of cards. Yeah, some people will be more specific about it, but most often I see is like they kind of abbreviate everything. That implies the type or the the quantity or the cost or whatever, right? Yeah, I would just leave it like that. Type 1 cards, the number of type 1 cards, the number of type 2 cards. There, that's what I mean. Some people are more specific about it. I'm sorry, the second equation?
And the second equation, it would be like x plus 3y equals 50.
Yeah, you got it, dude. So this is the cost equation. You can emphasize the one if you want, like $1. Some people do the dollar symbol here so that you don't forget the equation is relating to like cost. It's about cost, money. So I don't do that. I just want to be clean because I already defined the variable or declare it or assign it. I don't need it. I know what the answer should be, the units. I know the answer is going to be the number of cards. So anyway, even though this is the cost equation, all right, what method we solve it by elimination? Okay, how would you do it?
So I would probably multiply like the top by -1.
Yes, that's what I would do. Yep, very good. So here I will rewrite it right above it. Negative x minus y equals negative 24. Is that okay? Yeah, I do that. I won't even scratch it. Some teacher don't like you to scratch or erase anything, but but don't go back and use it. I'm sorry. Oh, I see. I know exactly. Let me rephrase that. Teacher don't like you to scratch things out because you know how you back substitute it or check and all that. It's very awkward for you to look for it because you scratch them out. So just leave it alone, but then just I this equation and this equation, and then combine them. All right. Now what do we do?
So then
We add them straight down.
Yeah, you add them.
Okay, let's do it. So that this cancel with this. So you're left with 2y equals, what is that, 16 or 26? 26.
Yeah.
26, right? Yeah, 26.
Yes.
Divide both sides by 2. So y equals 13 cards. 13 cards. The type 2 or the other type. But you don't have to specify that. Some teacher wants you to write a sentence. I don't think so because you're pretty up there. You're accelerated in an accelerated course, so I don't think they care for that. Cards on cards, 13 cards, and then plug it back in. I would use the original. I would use the original here. Is that okay? X plus 13 substituted for y equals 24. I'm substituting 13 for y. Subtract both sides by 13. X equals 11 cards. At least I put the units there. Notice I can use the original, the non-modified equations. You can use as long you get one answer out of it. However you did to get the answer, you mod it by timing everything by -1. You're fine. You can go back and use any of the steps that you ever written to continue or to check whatever you want. Actually, when you check, you should check the original. Sorry. Anyway, next number.
Next one, 40.
40. Okay. All right. On the first day, a total of 40 items were sold for this much, $356. $356. Define the variables and write the system equation to find the number of cakes and pies. So it's about cake and pies. You have to look at the price on, the tag right there, the price for the pies and the cakes. So let's use. Is it okay? Well, let's use the B and the. I'm sorry, the P and the K and P and the C. Let P. They capitalize it. Might as well capitalize it. You don't have to, but I'm gonna capitalize it. Let P be the number of pies. Some teachers don't like you to use the pound symbol. That's that number symbol. Just write the whole the word number. And then C, the number of cakes. All right. how now? Let's set up the equations.
Okay. So I think it would be P plus C equals 40.
Yes, and then
And then the second equation would be 10P
mhm.
plus 8C equals 356.
Yes, that's it. 356. That's it. The second equation is relating to cost in dollars. Again, we don't care for that because your answer will be the number of items, number of cakes, number of pies. Now, there's no decimal here already, so we don't have to worry about it. We just solve it. Solve using elimination. Okay, what should we do?
We could do like timesing the top equation by -8.
Okay, now check this out. Now I know I mentioned that. Hey, if these coefficient numbers and the constant back here is like divisible by something, you can make them smaller, but we don't have to always do it. Like this here, I don't know if, for example, nothing can divide into all of this for sure except two that right? Two for sure, they're even. But then it's not going to make a much difference because hey, it's a 5, a 4, and half of that. It's still going to be 3-digit. There's only one that has eliminate into 1-digit, it's into 1-digit. So it's not going to be. I wouldn't do it. It's okay. I would not make it smaller. Yeah, unless it's like all of them gone or something. Maybe okay. The coefficients gotten really really small. But yeah, I would do exactly this. So let's do it. So it's negative 8p minus 8c equals negative 320. Yeah.
Yeah.
All right. Let's add them straight down, and I'll put a bar here. I think that's what everyone does. If you add them straight down, you get 2p. Eliminate the c's equals, what is that? 36. Yeah. And then divide both sides by 2. P equals 18. So that's done. 18 pies. So I'll write 18 pies like that. And then plug 18 back into the original. I would use the first equation.
Yeah.
So it'll be 18 plus C equals 40. Subtract both sides by 18. Yeah, I have great confidence that you can actually interpret the word problems because you proved that to me last time on that worksheet. That's actually, to me, it's more challenging than these ones we've done so far. Anyway, what is this going to be? 22? Yeah,
Yeah.
22 cakes. But they make you practice, so I'm glad, over and over. So there's 18 pies and 22 cakes. You can always check them if you can. I already see that the first equation works. You should check both, but normally it works automatically if one equation works. Anyway, next one is which one? 4950?
Yeah.
Let's see here. Oh, let me do it on the bottom here. 49. All right, let's see. Tiona has saved dimes and quarters in her piggy bank. Okay. Define the variables. Okay, so it's all based off like the illustration now. Okay, $4 total in the piggy bank. There are 25 coins, right? Let's do the defining the variable or declare or assign. They say different in different textbooks. Declare, define, assign the variables. So let this one we can be specific. Lowercase d for number of dimes. Again, you can write the word number, okay? If the T doesn't like the pound symbol, number of dimes. And Q, this is my Q, the number of quarters. Okay, yeah. All right. How would you do this one? The yeah, the coin will highly likely be on the test or quiz. Yeah.
So what I would do D plus Q equals 25.
Yep. Okay. Good. That's your first equation.
Yeah. And my second equation, it would be point 10.
Mm-hmm. Plus.
Point 10 D plus point 25 Q
Uh-huh.
equals 4.
4. Yep. Now, if you do point, I recommend you put the zero placeholder. In like physical science, in physics and chemistry, they're gonna force you to write that. So it's a safe bet thing, so you don't make mistake. With the decimal. Sometimes you ignore it. You forget about it. It changes everything. So that's done. Now, again, you don't have to actually make this into non-decimal numbers. What do you think? I will still do it. Let's do it, right? Let's multiply the second equation by what?
I would multiply the second equation by 100 to remove
100?
the decimal.
Yes, let's do it. So we do that first. So it's 10D plus 25Q. 4 times 100 is 400. There. And what method are we doing again? Are we doing, use the best method. In my opinion, either one. But if I were to do it, I do substitution because if you bloat it up, you can make mistake. Let me give you an example. Now, don't worry too much because you already practice enough, but there's a chance watch, if I multiply everything by negative 10 here, right? Multiply, right? You're bloating this equation up, and just by doing that, you're copying the next equation, replacing it. All that time that you spend, there's a slight chance that you can forget something, a sign negative or a number being wrong, the digit. So the minimal number of things that you write, I would go for if I can, if they let you. So I would do substitution here, like solve for D here. So here, subtract both sides by Q. So it'd be 25 minus Q. Is that okay? For the first equation. So this might be my first. This would be my second equation. It's up to you. I would do it. I would do it like that. So it's minimal of things that instead of expanding things up, when you expand things, you rewrite. There's a chance. It's not a big deal. It's just like, I don't think it's a big deal at all. Some people like doing that, but some people like the elimination method. But yeah. So anyway, I'll do that. That's my choice for this one. So substitute D with 25 minus Q plus 25Q equals 400. So all that together. If I distribute, it'll be 250 right here, 10Q plus 25Q equals 400. You see my point, right? About, writing too much and all that. Yeah. 250 plus 15Q equals 400. Subtract both sides by 250. 15Q equals, what is that? 150, I think. Yeah. And then divide both sides by 15. Nice number here. So Q, the number of quarter is 10. 10 quarters. 10 quarters. So I'll write that unit right away. And then plug it back into the, not the original. Check it out. Because remember, anytime you manipulate and you solve for something, you got something already. You're free to use anything you've written here. So I would use this one. And this is going to be a common thing that you would do like for word problems in the future. For algebra, no kidding. You don't need to system equation or not. You look for something that's kind of straightforward. It's already there, especially a system of equation. So d equals 25 minus 10. And that will give you 15 dimes. There you go. And you can kind of check it. Yeah, 15 plus 10, 25. And the other ones, I just kind of trust that it will work. The 0.10 times 15 plus 0.25 times 10, all that will give you 4. It will, yeah, it will work. You can check them if you want. All right, 50?
Yeah.
All right, let's see.
Okay.
It's about the fair, country fair. The cost for 4 slices of pizza and 2 orders of French fries is $21. The cost of 2 slices of pizza and 3 orders of French fries is $16.50. Find how much each single slice of pizza and order of French fries cost. Okay, yeah. So let's define the variable or declare it. Let
I'll put
p
like pizza
okay
equals P.
p for the number of slices of pizza, number of slices.
Yeah.
This one we could be more specific because of that order of French fries. Watch the second one, slices of pizza. And then what about the second one? What do you think? French fries. Want to use F for French fries.
Yeah.
So
Yeah.
I would specify it like this: the number of orders or orders of French fries. Oh yeah, check this out. You can eliminate the phrase number off, just order of French fries. Yeah, they shorthand everything nowadays. But I remember that I used to have to write this number off. I remember, I don't know, depending on the teacher. I remember I was like, that's a lot of writing. Orders of fries. Order fries. French fries, yeah. Just shorten it. Or at least I shorten that. French fries. All right, how would you set it up?
So I would probably set it up 4 times P plus 2 times F equals 21.
Yep, looks good to me. 21. Yeah, double checking for that at the county fair. Yes, but then the cost, is that right? Double checking 4 slices pizza. Yeah, that looks good to me. 21. And what about the second one? The cost of 2 slices.
So it'd be 2 times F plus.
You mean 2 times? You mean 2 times P, right?
Oh yeah,
Yeah.
10 P plus 3 times F
Okay. 1650.
equal 16.50.
Okay, now I was kind of like pondering over. I was like, why is it having to be like 2 scenarios there? I was thinking that, hey, they should be more like this. This is what I think. They should actually say 1/10. This is how much you got. The second 10, because they may have different prices for you. The same type of things you're buying. So that makes more sense. I don't know whether this is exactly coming from the same, tent where they sell the French fries and the pizza. I don't think we need to care. We just solve it, right? Okay, now before we solve, yeah, this thing right here. here it is. This is the first time I think that we don't have to multiply this thing by 100. You could still do it unless you teach her, hey, always do it. I don't think so. Now, if you don't do this right, you have to deal with the decimal. For me, it's about the same amount of work. That's my opinion. But let me double check. Yeah, that's my opinion on this one. Do you want to see it like without having to multiply this one by 100? You want to try without it? Yeah, just
Yeah, we
for
could
the
try
sake.
about it.
Yeah, let's do it because in moving on in later math, you you realize that it's too much you have to do. Therefore, oh, I know. You're allowed to use a calculator. Like especially in later math, especially in pre-calculus, word problems, always calculus, no problem. Therefore, that's why this decimal, we're bloating up, multiplying it by 100. It's irrelevant. It's like you don't care because your calculator is near you. Like you just punch it in. So that's why this is like what it reminds me of. Okay, so I believe even in algebra 2 word problems, when it gets really complicated, they allow you to use calculator. Oh, I'm sorry, in algebra 2, yes, they're already having you use calculator for graphing. You're already using calculator for different things. Therefore, you're likely to be allowed to use it for word problems as well, to speed things up because the concept is already kind of new and you have to learn it. And it's like too much already. You've done your arithmetic. That's why. So let's do it. Okay. But what solved system? It doesn't say. Yeah. So best method. What do you think? What would you do?
I'll probably multiply the bottom equation by -2.
Okay. And just that. Right. Yeah.
Yeah.
Because you want to eliminate this. Okay. Let's do it. So it'd be negative 4p minus 6f. Just double 16, 50. So 16, if you double 16, that's 32. If you double 50 cents, that's 1. That's why it's $33. Take a look. Look how it works out nicely. Double check my math there. Yeah. 216 is $32, right? And then 50, that's a dollar. So that's 33. Look at how nice. See, it's gone. That blowed up, zeros and things. It's gone. The decimal's gone. Look at that. All right. Add them straight down.
Mm-hmm.
You get a negative 4f equals, what is that? 54. Okay. So divide, yeah, double check my math there. Okay. So did I make a mistake? Because, yeah, I did. I forgot to make this a negative 33, right? So careful.
Oh,
See that?
yeah.
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 Yeah. Oh, yeah. This is for learning reason too. If you realize your answer coming out weird, because this is relating to the number of items, so you should not have a partial or a half or a decimal. You know what I mean? So yeah, this is good. I'm glad I made a mistake here so that I can talk about it. All right. So let's see. What is that? 21 subtract 33. So it's what is that? 12? Negative 12.
Yeah. Yeah.
So therefore, divide both sides by negative 4.
3.
Be 3 for the number of, what is that? Order of French fries. 3 orders. So 3 orders of French fries. FF. Okay, and then plug it back in. I plug in the original because I don't want to deal with the decimal. So yeah, is that okay? That'll be 4p times 2 times 3 here. It'll be 6, but I'll write to show the work. Equals 21. So it'll be 4p plus 6, 21. Equals 21. Subtract both sides by 6. What is that? Okay, unless I made a mistake somewhere. 3, right?
Yeah.
That was 6. Wait, this is good. I'm glad like we get to check what's going on here. Double check everything here. 2 times number of French fries, that's 6 and 21 cost. And order 3 French fries, 2 French fries, and then the other one costs 2 slices of pizza. What's that much? Oh, let me see. Read carefully. Find how much a single slice of pizza.
Oh, so I think it might be okay if it's decimal because it's cost.
Yeah, it's actually, this is about how much. Yeah, I'm sorry, I didn't read. I didn't read. Yeah, how much is single slice? So it's okay. Okay, good catch there. Yeah, I didn't read. I thought it'd be a number of items, but I'm glad we checked it here too. Like negative, being a negative answer and all that. Okay, cool. So what is that? 15 or P? Okay. So
Yeah.
let's see. 15 divided by 4 in terms of money. Okay, 15 divided by 4. It'd be $3.75 for the pizza. 75. So erase this unit and put dollar symbol there instead for the French fries. Is that okay?
Yeah.
Yeah, that's it. So let's see. What did we solve it? Yeah, the best solve for find out how much a single slice of pizza and order French fries. Yeah, that's it. So it's a $3 for an order of French fries and $3.75 for a slice of pizza. Okay, looks good. All right. Is that okay?
Yeah.
Yeah, Alex, looks good.
Yeah.
Yeah, I'm double checking. Yeah. All right. We'll carry on. Just quickly, can I ask again for the graphing? I forgot to ask specifically what method have your teacher shown you for graphing? Is it the y equals mx plus b or this intercept methods, the x and y intercept?
She showed us like the slope intercept form for the graphing.
Yes, like the one I did solving for y's, right? Like here, right?
Yeah.
Yeah. But did you get how I also did it like the other way? Like, like the 2 points, you connect them. Did you get that? You want to quickly look at it again? If you eye this quickly, it might look at the intercepts. Just you don't have to worry. Just go ahead and make 1 0. Don't worry about the order. You could do whichever one first. If my y is 0, my y is 0, my y is 0, my y is 0, my x is 14. Y is 0, x 14, right there. Yeah, right there. Then you have to stay on the same equation. If my x is 0, my y is 14. There is my second point. Then you connect them. You see that? Yeah, you connect them. So this is pretty easy now. The reason why they don't always use this is because sometimes if you do this with like a 2 in front right here, like for the second equation, you're not going to get a nice even number. You're going to get a fraction. See this one, since this one does not have any weird number, you can do it quickly. So you just connect them. Same thing, watch. When x is 0, x is 0, x is 0 for the second equation, x is 0, your y is -4. Divide both sides by -1. See that? Y equals -4. Divide both sides by -1. So it's -4. There it is. And then you do the other one. If your y is 0, your x is 4, your y is 0, x right there. But when you connect them, you have to extend it until the same slope. You have to keep rise run it until you intersect the other line. So yeah, anyway, that's